All right, guys. How you doing? I'm so new at this and just trying to figure out how to do all this. So, how are you doing, April? And Gabe? April, by the way, before I forget, if you get on the Abeka website, it's going to look like you already watched some videos for a few minutes. You didn't really. I just used your account to get on there. I walked through it, so I was able to type out on the email the process of getting into your account and watching the videos. So you really didn't watch anything, so I hope that doesn't mess anything up. I did mention to your parents that the videos are a little bit long. The math one isn't too bad, and the math one would probably be the best one for you guys to watch. If anything, just watch the beginning part because they do review, and that will be helpful in remembering some of the facts that you have to remember that we can't really review together, obviously, because we're not in class. And as I look at this lesson and some future lessons, we may have to use our compass protractor, and I'm not going to be able to do that on the lesson. I can maybe talk you through it, but will not be able to do it. Obviously, I can write on these pages, but I can't really use a protractor or a compass, really. All right. Anyway, so today we are going to construct circle graphs. And they give you a picture over here of John's donut shop. 40% of the donuts he makes are glazed, 30% are jelly, and 30% are cake. I don't know if my pencil's writing. Let me try this again here. Second. No, I'm writing. Watch this. It's really cool. I can erase. It's pretty cool. Now let me go back to my pencil. All right. So they want you to use a compass to draw a circle with a radius of 1 to 2 inches or 3 to 5 centimeters is a good size. So I would suggest that you get a blank piece of paper, get your compass out, and remember when you set your compass, you are setting it for the radius. So they don't have an exact size here. They just want your circle to be somewhere between 1 and 2 inches as a radius, which will make your circle 2 to 4 inches in diameter. So you can go ahead and do that. You can pause if you want to go ahead and make a circle. After you make a circle, we're going to find the number of degrees in each angle based on the statistics. For instance, if John bought 4 glazed donuts, 3 jelly donuts, and 3 cake donuts, his total bought was 10 donuts. Find what percent of each number of donuts is of 10. For instance, glazed, if he bought 4 glazed donuts, that would be 4 out of 10, and that is 40%. If you are forgetting, remember you would do 4 out of 10. You would reduce that to 2/5. And if you remember, 2/5 is 40%. Or if you totally forget, you could do 2 times 5. Add a decimal. 5 goes into 20.4 times. That's 40%. All right. So we have, let me find my spot here again. We have the glazed donuts at 40%. The jelly donuts, he bought 3 jelly donuts, right? So that's 3 out of 10. 3/10 is 30%. And the cake donuts, he also bought 3 of them. So that's 3/10. So that's also 30%. All right. So the question is, how big do we know to make each segment of the circle? So it says here, then find the percentage. The number of whole degrees in each angle by multiplying the percents by 360. And why 360? Because a whole circle from start all the way around is 360 degrees. Remember when you have your protractor is a semicircle or a half circle. and one side would be 0 and the other side is 180. Half a circle is 180 degrees. 180 degrees twice is 360 degrees. So with the first one, the glazed donuts was 40%, right? So I'm going to write over here. My paper is going to be a mess. But anyway, 40% or 0.40 of, which is times 360. Okay? And if you multiply those together, I won't do it on this one because we'll have to do it down here. If you multiply those two together, you would get 144 degrees. And then you would do 360 times 0.3, the 30%. And that will give you 108 degrees. And then the other one's exactly the same at 108 degrees. So we have three measurements. We have 144 degrees. We have 108 degrees. And then another one at 108 degrees. All right. At that point, on your circle, which I obviously can't do with you, you're going to put your, I'll just draw a little one here. Make your center circle like that. And then anywhere on your circle, make a straight line. And I'm doing this freehand on here, but do a nice straight line with your protractor. At that point, put your protractor on there and somewhere measure 144 degrees. Can you guys close the door for me? Now the cat's in here, Josiah. This is 144 degrees. Sorry about that. And then you're going to turn your page around. So this can be the bottom or this can be the bottom. And then you're going to measure 108 degrees, and that's probably not accurate. And then the other one would be 108, and that's totally not accurate. But that's how you're only going to have to measure the 108 because the third one will be what's left over, which would be 108 degrees. All right, I hope that's not too confusing for you. All right, let's look down here at number 1. Complete this chart. Find the percentage to the nearest whole percent. Then find the degrees to the nearest whole degree. So we have 4 different kinds of trees. All right. Within those 4 different kinds, you have 8 oak trees. You have 6 pine trees, 5 dogwood trees, and 3 poplar trees. All right. So how did they figure out the percent? Well, it's 8 oak trees out of how many altogether? And let's add these up. 8 plus 6 is 14. 14 plus 5 is 19. And 19 plus 3 is 22. So it's 8 over 22, which reduces to 4 over 11. Okay, and now we have to change that into a percent. Let me erase a little bit over here so I have some room to work. All right, go back to my pen. So it's 4 divided by 11. You should probably do this on scrap paper, but I can't put a piece of scrap paper on here. Add a 0. 11 into 40, 40 would be 3 times, which is 33. With 7 left over, bring down another 0. 11 in, don't forget to put the decimal there. 11 into 70 would be 6 times, 66, with 4 left over. And let me see, yeah, they're going to take it out another degree. Another space, another spot. Here we go. 11 into 40 is 3 times, which is 3. And that would just keep going. It will never come out. But once we have 3 places, we know whether to round this up or keep it the same. And do you remember what to do? What will the 3 do to that 6? Yep, it'll keep it the same. So it's 0.36 or 36%, which they have right here. Then the question is, what part of the circle will that be? And let me erase again. Go back to this. All right, so you take 0.36 and you're going to multiply it by 360. And if you do that properly, you should get 130 degrees. All right, let's do the next one together. Let me erase. All right, so for the next one, we have a pine tree. There's 6 out of 22. So we have 6. Oops, I gotta get back to my pen. 6 out of 22, which that reduces to 3 over 11. Now we're going to divide 3 by 11. All right, 11 into 30, twice, 22. Put that decimal up there. 8, 11 into 80, 7, 3, 11 into 30, twice. And at this point, we're going to stop because we only have to go 3 places. That 2 is not going to change that 7. So we have 0.27 or 27%. After that, I'm going to work down here because I can erase it. Do 27 times 360. And remember, I like to do my little, let me erase here, my little trick. Let's just do it by 36. Whoops. Here we go. By 36. And we'll add the 0 when we're done. 42, 21, 25. Unfortunately, I don't have you guys here to holler at me if I make a mistake, do I? Let me look at my teacher book, make sure I got that number right. Yep, looks right. All right, and then to add the 0. And this was 30.36, so 2 places after the decimal. This 2 will not round that 7 up, so we can say 97 degrees. All right, let me get rid of this. All right, now let's do the dogwood. All right, back to my pen. All right, so the dogwood is 5 out of 22. That does not reduce. So right off the bat, we're going to do 5 divided by 22.0. 5, that would be 2 times, right? 44 with 6 left over. I can't write past this page, can I? I'm going to be really sloppy here. 22 into 60. What would that be? 3 times? No, 2 times. Be 44 again. And that would be a remainder of 16. And then add another 0. I'm not going to be moving over because I can't. I'm out of page. All right, 22 into 160. It looks like on my teacher book we're about 7, which is 14, 15. Now at that point we can stop because we have 0.227. Let me write it over here so you can see. That 7, we'll round that 2 up to a 3, so we're at 23%. Let me check my book, make sure I have the right answer here. Yep. All right, now we're going to do 360 times 0.23. Let's just do 36 times 0.23. 18, 9, 10, 12, 7, 8, 2, 8. Add a 0. 2 places after the decimal. That 8 is going to move that 2 up to a 3. We just want to be in a whole number here. We don't want decimals or fractions in here. All right, let me erase again. I know this is tedious, isn't it? But if it's any consolation, this is all you have to do on this page. Oh, come on. Crazy, isn't it? You with me? Gabe, you're not asleep, are you? Okay, here we go. One more. Poplar tree is 3 out of 22. That cannot be reduced. Remember, there's 22 trees total. We added up all the trees over here. And there's 3 poplar trees. I don't want you to forget that. So it's 3 divided by 22. And I'm going to round space again. That's 1 time, 0.1. 22 That's 8 left over this time, right? This would be, what, 5, 4 times would be too big, so 3. And that would be 66. And that would be 14, add a 0, and that's going to be more than 5, so I know I have to round up, but 22 in 6 times, will that work? I think so. 12, 13, yep, that worked, and that's pretty close. All right, so that 6 is going to round that 3 up to a 4, so we're at 14%, okay? All right, now we have to do 36 times 0.14. Actually, it's 360. I'm just leaving that 0 off for now and ignoring it so I can add it in at the end. Remember, I told you it's my little trick. All right, 14, 20, 12, 13, 14, 6 and 3. Did I get it right? I think so. Okay, add that 0 in 2 places after the decimal. That 4 will not change that 0. So we are at 50 degrees. All right. Do they want you to draw the circle? Not on this page. Okay. Now I'm going to take a second here to get to the next page. Let me see if I can find it. Oh, it never works for me. It works so easy for Ron. You made some... I don't want to do that. Oh my gosh. There we go. There's the one we just did. Is this the back? This is the back. Okay. So now you have to draw your circle. And this is where I cannot do this with you. So take your time and get a blank sheet of paper out and make a circle big enough. Don't do it on another piece of paper. Don't do it on here. Okay. Make a circle big enough that you feel comfortable with. And I cannot make a perfect circle freehand. Okay. So you can pause it and make your own circle. And then after you make your circle, I want you to take your protractor, and I'm making a freehand line. I want you to make a nice straight line with your protractor. So we have 4 angles. All right, the first one is 130 degrees. So from there, you're going to measure, you're going to put your protractor, put your little circle there, put this on the bottom of your protractor, and you're going to measure 30 degrees, which is 130 degrees, which should be somewhere around there. Let me look at my book. Okay, mine's not like theirs anyway. And then you would label that 130 degrees. And then after you do that, you're going to have to turn your paper around and make either this your bottom or make this your bottom. It doesn't matter. And then you're going to measure another one. Let me go back to my page. One that's 27 degrees. And I'm going to pretend this is so it's going to be somewhere like that. Okay. And then you're going to measure another one that's 23 degrees, which is slightly smaller. And I know I'm extending these, but you shouldn't. You should probably just end right at the end of the circle. And then you have one more that's 50 degrees. Oh, no, you have... Oh, wait a second. I'm doing percents here. It's getting dark in my bedroom here. I hope we get back together soon. Like that. All right, now make a straight line. All right, I started reading my percents because my room's dark. Okay, go like that. It's not late. It's in the middle of the day, but it's getting dark outside. 130 degrees, and then we have like a 97. How about that? And then we have an 83. So obviously, guys, I'm freehanding this, and it's probably a mess. If you're having trouble measuring them, get somebody older in your house or a parent to help you measure those. Remember, this goes in the center of your protractor. This goes on the bottom, or any line can go on the bottom. And then like your protractor sitting on here nice and big, and say this is 90 degrees and this is 130, so you'd put a dot there and then you'd connect it. Remember that? I know it's been a while. Okay, boy, I'm a little bit over that. Draw a circle graph to illustrate. Oh, that's a lot of work. How about we skip this one for now? Okay. All right. Let me go down here. I forgot to tell you. I told the 5th graders, because we're not together, I want you to do the whole lesson. Okay. The green ones, like here, I believe this is green. I can hardly see it on my screen. But all the green ones will still be extra credit. Okay. And that would be even in the new section. I don't want to take a chance and go back to the first side. So anything on the first side that's green will still be extra credit. So if you do it, that will help your grade. I want to just do this one with you, and I think I'll be almost done just because I want to. All right, so the first thing you have to do, they give you a circle, and its radius is 5 inches. All right. First, they want you to they want you to find the circumference. Remember, circumference equals pi times diameter. If they give you the radius, remember you just take the radius times 2. You just double it. So if the radius was 5, then the diameter is 10. So it's just 3.14 times 10. Okay? Anything times 10, you're just moving the decimal over once. And that answer, this one would be 31.4. That answer is just inches, not square inches, because we're just doing the distance around our circle. We're just doing a length, right? Remember that? And then the area of the circle, this is different. Remember, it's pi times the radius squared, not the radius twice. The radius squared is the radius twice. So here they give us the diameter of 6.2. So the first thing we have to do is half that and make it a radius, which is 3.1. After you make it into a radius, then you can multiply it by itself, and you should get 1339. Put your decimal in, 9.61. Let me check my answer book. Yep, 9.61. Then at that point, and I'm not going to take the time to do it, you can do it. Do 3.14 times 9.61. Multiply that out, and just make sure you have 4 numbers after your decimal when you're all done. That answer is going to be in square feet or feet squared, however you want to write it. Okay? Perimeter of a square, you're just adding up the sides. Or you can do the sides times 4. Okay? Perimeter of the rectangle is just adding up the sides, or you can do the length times 2 and then the width times 2, because what you're doing, you're just either going to make 2 lengths, 2 widths, right? So you do this times 2 and this times 2, and then add them all together. The area of a triangle, you have a triangle, they're giving you the base of 14 and the height of 7. The area of the triangle is just like squares and rectangles and parallelograms. It's base times the height, but a triangle is half of all those. Remember, if I take a rectangle and cut it in half, I get a triangle. So you do the base times the height, and then you half it. Remember, the little trick was, if one of them's even, you can half it right away. And if I look at my base right here, my base is even. So I could half that base right away and make it 7. And then just times it by the height. And then I don't have to do this part because I really already did it. So 7 times 7 would be 49. So that would be 49 square feet, or you can write feet squared. I'm giving you a lot of these because I know we're just get back into our groove here. All right, the area of the parallelogram. Area of a parallelogram, we just call it base times height, because in a parallelogram, the sides are actually longer than the height. And so what they'll do is they'll give you the base, which is 9 2/3, and they will give you the height, which is 6 1/2. Change these guys to improper fractions first, then multiply them. And it's area, so it has to be square. Don't forget down here, whoops, don't forget down here, you got to move this guy over twice and move this over twice. Remember with adding, keep them lined up. With the subtraction, put zeros here. And then just subtract normally and just bring down your decimal. Big thing, this guy right here, exponents. This isn't 9 times 3. How many times can I say that, right? It's 9 times 9 times 9. So multiply these two guys together and then multiply it by 9 again. And that'll give you your answer. All right. I think that's it for this lesson. Just so you know, don't ever hand a math paper in looking this messy. It's terrible, isn't it? I would write sloppy at the top, and I'd say, no, and take some points away or take some stickers away from you, which I can't. But I think I did pretty good for doing this for the first time. You guys have a great day. Hopefully this helped you. And if you have any questions, you can always call me or text. Just text me and say, hey, can I call you? And if I'm available, I'll call you right then, or I'll call you back soon and help you whenever I can. I miss you guys a bunch, and I'm going to try to log off now. So give me a second here. I got to go into here. I don't even know if you can see this. I'm going to stop. Bye.